limit of sequences. Now, when you're talking about the limit of a sequence, you're looking at a number as you list the terms of a sequence and you go on and on and on. There's a certain number that they seem to be approaching, and it will never reach that number. Either it will never go higher nor lower than that number, and that is called the limit. For example, let's say, let me see something. Let's say you have, let me get a ruler. I have my ruler here. Turn my ruler sideways. Now, you have a piece of board 15 centimeters long, and you decide, alright, 16. It's 16 centimeters long. It seems to be 16. Alright. Let me lengthen my ruler a bit. Alright, just about 16. Alright. And you decide that you're going to cut that board in two halves. You cut and you put half in a box. So now you have half the board. You cut it here, so you have half the board. Then you cut in half again. So first of all, you had 16 centimeter. Then the next board that you have is 8 centimeter. You cut it in two halves and you have 4. So in that case, you now have a piece of board 4 centimeters long. So it's 4. Let me write that properly. You have 4 centimeters. And you cut this board in half again. So it is now 2. So you now have a piece of board 2 centimeters. That 2, you cut it in half again. So you have 1. So now you have a piece of board 1 centimeter long. Then that 1 centimeter, you cut it in half again. So you have half a centimeter. So you now have a piece of board that is half centimeter long. And you cut it, that piece of board in half again. So you have quarter centimeter. A quarter centimeter. And you keep doing that. You will reach a certain length. What would that length be? Now, what you say here, first of all, let's look at what would happen. We started here 16, then 8, then 4, 2, 1, 0. What do you think? It's heading, the length left over is heading towards 0 centimeters. That's where it's going. The thing is, it will never reach there. Theoretically, it will never reach 0. It keeps getting approached. It keeps getting closer and closer to 0. And no matter how many times you ask, are we there yet? It will never reach 0. Even if you cut it down to 1 atom, an atom is not 0 centimeters. And if you take out one of the electrons, one of the proton or the neutron, you still cut it and cut it in half, and no matter how you cut, you will never reach 0 centimeter. Theoretically, you will never. So, in this case, it is tending towards 0, but will not actually touch 0. Alright? Now, suppose we have a case like this. 1, half, quarter, 1/8, 1/16, and so on and so forth, alright? You can say that U1 is 1, U2 is half, U3 is a quarter, and so on and so forth. And how you actually get the particular term is to say, what you can do is say, you get 1 by saying half to the power of 0. Second term, half to the power of 1. And remember, you have to review your indices to remember that when you raise a number to a power of 0, the answer you get is 1. You raise a number to a power of 1, you get the number itself. To get the 4, U3, you get half squared, which is really half by half. And up top, multiply fractions. 1 by 1 is 1, 2 by 2 is 4. See that? What about the fourth term, 1/8? How do you get that 1/8? It is half to the power of, remember, first term, the power was 0. Second term, the power was 1. The third term, the power was 2. The fourth term, the power is 3. A half cube is really half by half by half. So when you multiply them, 1, 1, 1, 1, 1, 1 up top, 2 2s 4, 4 2s 8 down the bottom. And then for the fourth term, what you're going to have, let me erase these things. The fourth term is 1/16. So what you do is say half, 1, 2, 3, 1, 2, 3, 4, fifth term I should say. So what you do is half to the power of 4 is really half by half by half by half. So up top, 1, 1, 1, 1 time, 1 time, 1 time, 1 is just 1. 2 2s 4, 4 2s 8, 8 2s 16. Okay, good. So we can say that for this term, UN equals half to the power of, remember, for term number 1, you raise to the 0. For term number 2, you raise to the 1. For term number 3, you raise to the 2. So whatever the term number is, you minus 1 from it. Alright? Because you can actually rewrite this and say instead of 0, you say to the 1 minus 1. Instead of writing 1, you say second term is to the 2 minus 1. Third term, the 3 minus 1 term. Fourth term. If you want to write the term number in it, instead of writing 3, you write 4 minus 1. So the power is really to the position minus 1. Fifth term, instead of to the fourth, you write to the 5 minus 1. So it's half to the n minus 1. Good. That's the nth term. Now, this term tends towards 0. Now, let me erase this part here. Here now, the limit of this term is 0. Now, when you say the limit of a term, you're talking about the number that the terms are approaching, right? So, in plain English, you can say that the limit of this term, whatever term it is, or the limit of the sequence, right, as the number of terms approaches. Now, the thing is, the number of terms is really the position of the term, alright? The number of terms, not the total number, because this doesn't give you a specific number of terms. It's the position of the term. So, as the number of the nth term approaches. Now, instead of writing number of the nth term, let me put it this way: the limit of the sequence, right, as the nth term approaches. Now, what I'm doing is fixing up the meaning of the symbol that I'm going to write. Now, in this case, I'm going to approach infinity. It could be that you're approaching some other number. Now, how you write this, the limit of this term is to say, right, here, what this is saying is the limit of this function as n tends to infinity. So, instead of saying approaches now, we change this to tends to. In this case, it is infinity, meaning you spend all day, all week, all year, and write the term forever and ever and ever, and you still can't finish. So as n tends towards infinity, what is the limit of this term? And we have seen that the limit of this term is 0, because they keep getting smaller and smaller, so they tend towards 0. So the limit of this term actually exists, and it is 0. Alright? Now, before we finish this, the fact is, sometimes you might see a function like this and you're required to find out what the limit is. If this is a function, it may be written instead of half to the n minus 1, it's the same thing as 1 over 2 to the n minus 1. Alright? You probably have recognized that. Alright? You probably recognize this already. Same thing. But there's something here that you want to say. This number in the denominator will get larger and larger and larger. However, when you work it out, 1 divided by a large number is a small answer. Alright? Just like how 1 divided by 2, yeah, no problem, that's a half. But as the denominator 2 becomes 4, then 8, then 16, and goes up, and the number at the top remains, the answer gets smaller and smaller. So that's the reason why it tends to 0. So the limit of this term is 0. You see that? Or the limit of the sequence, I should say, is 0. The limit of this sequence is 0. What we're going to do is look at a few more sequences and see if we can figure out what the limit of those sequences are. So I will see you.